the French being the French, they didn't, but that's a good part of it. What happened is that you combine the concept of rules with the concept of probabilities. And the two together are going to play in order to evaluate the situation. In this particular case, I have the rule, for example. So what we see here, and you will have to have a very impressionistic view of it, but on the top right are the objects we are talking about. On the left are the list of those rules which correspond essentially to what a neuron does. And in the middle is the actual neuron. So what we have, for example, for nearer bottom, that's what happens when you get, when you're going to attack bottom. These are the typical sequence of events with their probabilities. So essentially, most of the time, you're going to circulate. Then you're going to probably rotate, or sometimes you just put the palm down according to the various probabilities. And using those rules in combination will allow you to find out what are the most likely situations in which we are in terms of a drilling context. I'm going to stop right here because at that point, before I give you the answer of the computer, I need to know how many people found the depths of these jobs. What is it? 1,260 feet. Okay, you're a contender. Where is more? 450? 400. So I have 100, 1,200 you said? 400? Okay, you get the lollipop. You're extremely close. I'll show you then why. The length of it. What is the length of the job? 9? I didn't hear. How long is the job? The duration, yeah. In hours, day, months. You should try. I mean, you have nothing to lose. If you give the wrong answer, you don't get a lollipop. 3 days. That's you're a contender. Four days. That's so now I need a third data point to make a line. Lollipop. This one is very hard. So what's happening here is that you notice that we go up here. We go up in slips in 2 stages. And the first stage is about, the last stage about 1/3 of the first stage. It means that we have the rig is a special rig, it's a 4-ball. So a stand, 3 pipes, then you have another pipe. So what's very interesting in this job is that there is a length of time between the 3 pipes and the 1 pipe, and that's with this very stable, and I know what people told me it could be, but I don't know what it is. But since you know now it's a 4-ball, you can look at those events, and then you get the depth, and the way the computer did it is right here. So this is full automated computer interpretation of the signal. I mean, totally automated. No human whatsoever. Just computer doing what the brain does. And what you see in light blue is the adding stand events. And for example, what you see here is exactly what I said. You see those adding stands, and you see it being done in two events. Right there, the first 3 pipes. Here is the last pipe. And we see the well going down, until here, where we are actually at 1,000 feet, which you can compute from the length of the pipe. The brown here is when we are making hole. Below the brown is whether we are making hole rotary or sliding, and so on. And we can see here the reverse. And if you remember the patterns here, you will notice that those very bottom patterns are very different. The in-slips pattern here are very different from the one on the left, because there is an asymmetry between the hook load patterns in adding stand and removing stand, which makes extremely difficult to put them in a similar category. Other events that you can see here are wiping holes, and in fact those are very easy to confuse with those, but the context makes it clear that we are actually wiping hole and not adding or removing stands. And then you have some very interesting patterns here that you see not very well here, but I wrote an article on it, so and I know it has been read widely, so people who have read it know what it is. It is actually something very interesting